Alright, so let's talk now about just some of the other properties of radicals. And again, this is going to apply to any radical with any index. It doesn't matter if it's a cube root or a square root or a fourth root or a 10th root. All of these properties work for all of our problems. Okay, so the first property that we want to remember is just how do we multiply together radicals? And the answer is as long as the index number is the same for my two radicals, all I need to do is multiply the values that are underneath the radicals, which we call these the radicands, multiply the radicands together, and put the product underneath the its own radical. So as a simple example, the square root of 8 times the square root of 2 is the same as the square root of 8 times 2, which is 16, and then I can say in this case the answer to that is 4. Right? So I can simplify that easier than if I were to simplify the pieces themselves. Okay? So if I take a look at this next one, same idea. I can say 16 times 5 looks like it's not, 6 times 15 is 90, x times x is x squared, and in this case I need to simplify this expression a little bit more. Okay? Sorry, I got a little extra line there I wanted to get rid of for you. All right, so I'm going to break this up into the square root of 9, square root of 10, and because this is index 2, I want to make sure that I have something that's divisible by 2 with my exponent, and what I have there already is, so I'm not going to change that. So this is going to become 3x the square root of 10, and that would be my final answer. Okay, but again, big idea here. If I ask you to perform this operation, just multiply the radicands together, and that product will go under its own radical that will have the same index that we started with. Right? So now let's talk about adding and subtracting. So adding and subtracting is different, right? Just like when we talk about variables, when we talk about variables, we say it's okay to multiply together things that are different variables, but it is not okay to add and subtract things that have different variables. So the concept of a radicand is the same. If I were to give you this problem and say 2 root 12 plus 4 root 27, I'm going to look at those and say that's like saying something like 2x plus 4y. And if I were to ask you to put those together, you would say, I can't put those together. They're different. They are not like terms. Well, we need like radicands in order to put things together. So I'm going to look at this one and say, I cannot, the way it looks, add these together. But the nice thing about radicals is that some radicals simplify. And in this case, both the 12 and the 27 do simplify. So this is going to become 2 times root 4 root 3. Okay? I have a perfect square in 12. And I'm going to do the same thing with 27. I'm going to say this is 4 times root 9 root 3. Okay? And now if I simplify it, 2 times 2, remember square root of 4 is just 2. So this is 2 times 2. That's 4 root 3. Okay? And 4 times 3, because root 9 is really just 3, 4 times 3 is 12 root 3. And now in their simplified form, it looks like they do in fact match each other. So I'm going to say now the way that we're going to add these together is to add together the coefficients. 4 plus 12 is 16. Don't change the radical at all. 16 root 3 would be my sum. Okay, and I can do this the same for subtraction. This square root of 8 is really 2 root 2, so this will become negative 14 root 2. Right? Just take the square root of 4 and multiply it by the 7. Right? And I can do the same thing with this. It will become 15. And here's the catch, though. After I simplify it, this one becomes 15 root 5. So even in their simplified form, in this case, I'm going to say, well, root 2 and root 5, those aren't like each other at all. So the best I could do with this one is say, I'm done right here. I simplified the two radicals, but they still don't have like radicands. And so in this case, I'm going to say, I'm finished. I can go no further. I cannot put those two values together. Okay, so be careful. Have to have like radicands to add and subtract. We don't have to do that for multiplication and division. Okay, so let's expand. Right, we want to be able to use radicals just like we use any other real number. And so if I were to ask you to distribute with radicals, this is really just multiplying and perhaps adding some terms together. So if I ask you to distribute, this is really just saying square root of 3 times the square root of 6, and also 7 times the square root of 3. So we just said a second ago that if I want to multiply together two radicals, they're allowed to have different radicands, and I just multiply them by multiplying them together. 6 times 3 gives me an 18. Okay. Square root of 3 times 7, this is not under a radical, so I'm not going to say 21. I'm just going to say take the 7, multiply it by the square root of 3. That's the best that I can do. Right? And so I'm going to look at 18 and say, well, let's say 18. That's something that's going to simplify a little bit more. This is the square root of 9 times the square root of 2, so it's really 3 square root of 2. and 7 square root of 3. So I'd say in simplest form, this would be my answer. Okay, so we can expand this idea of distributing to binomial expressions. So I can say something like square root of 5 minus 2 square root of 15 and 5 plus square root of 15. I can add those I can multiply those together as well. And so again, I got to go through this piece by piece, just like we did with FOIL. If I gave you something that said something like x plus 6 and x minus 3, we would multiply these by saying first term times first term. So let's do that same thing over here. Square root of 5 times the square root of 5 is the square root of 25. That's how I multiply together radicals. And then I'm going to do the square root of 5 times the square root of 15. Okay, well that looks like the square root of 75. So it's positive square root of 75. Now I'm going to take this whole big expression, negative 2 square root of 15 times the square root of 5. So how I multiply these together is multiply the radical with the radical. And in this case, there's a 1 sitting out here, so it'll be negative 2 times 1. So it's negative 2 square root of 75. Okay, and then I'm going to take the negative 2 as well, and I'm going to multiply it by this expression here, which comes out to be 2 root 225. Okay, so now this is where I'm at, and this needs to be simplified a lot. Right, so I'm going to start off with going piece by piece and trying to simplify my expression. So I'm going to look at this one and I'm going to say this is just 5, right? Square root of 25. The square root of 75 has a 25 in it, so just off to the side here, square root of 75 is the square root of 25 times the square root of 3, which I can simplify that to 5 root 3. So I'm going to say this is 5 root 3. Okay. This is also a 75, so it's another 5 root 3, but the 5 is going to be multiplied by the negative 2, and it's going to become negative 10 root 3. Okay, and then the square root of 225 is 15, so this is 2 times 15, which is 30. Okay, so I can put together some pieces now. So 5 plus 30, well, 5 plus 30 is just 35, so I'm going to write that down, like terms. And these two expressions can also be put together. My middle terms here both have a radical 3, and we just said a second ago that you are allowed to add and subtract radicals that have the same radicand. So I can say in this case 5 minus 10 is negative 5, and then I'm going to repeat the root 3. And so I'm going to say final answer is this. Okay. One word of caution. I see a lot of people that want to look at this 35 minus 3 and try to put those together. We are not allowed to do that because, remember, PEMDAS says multiplication must come before subtraction. And since I can't simplify 5 times the square root of 3, I can't do the subtraction either. Because this has to come first, I have to wait, and I'm not allowed to put these pieces together. So careful, common mistake, right, that a lot of people make. So, the last problem here is just a reminder that when you see squared on the outside of a binomial expression, that this really means the square root of 11 plus 2, okay, times the square root of 11 plus 2. And then after this, it's just really going to become another one of these problems. So I'm not going to go through all the steps again, but you get the idea. It's really just going to be another big distributing problem. Don't just square the parts. That's common mistake that people make. All right, so here's our last property that we're going to talk about today, or at least in this video, and that is what happens when there's a fraction under a radical. So the concept of a fraction under a radical is pretty straightforward. We're just going to say if there's a fraction under the radical, we can treat this like two separate problems. I can give the radical to the numerator and to the denominator separately. So for an example like this, I'm going to say instead of being one big fraction under the radical, I can say this is the same as the square root of 24 over the square root of 9. And then I'm going to simplify each of these as their own separate problems. I could say the square root of 24 is really 2 root 6, and the square root of 9 is just 3, and I can get my answer like that. Okay. And just as a side note, if there's a fraction underneath the radical that reduces at all, then that's something that you can do as well. So if you notice in this problem, 24 and 9 both have a 3 in them. So before I did the splitting, I could have taken this and said, well, 24 divided by 3 gives me an 8. And when I do this, it gives me a 3. Okay, and then I can try to deal with this thing. But if you notice in this case, it actually makes my life probably not as easy, because then I have radicals. My denominator doesn't, simplify nicely. So, but this is an option, right? We're going to talk in the next video about why this is a square root of 3 in the bottom is actually an issue. But we're allowed to simplify the fraction if we want, if it's helpful and beneficial to us, right? And I can do in this case, if you notice, I get 2 root 3 over root 3. Right, and I'm looking at this and saying, this is really, I'm sorry, 2 root 2 over root 3. Okay, and I'm going to actually say, this is not simplified yet, because our last step for radicals is I have to have no radicals in the denominator, so I'd have to keep going with this one. So if you notice, I now have more work to do by simplifying it than if I had have left it unsimplified. But there will be times where it's going to be easier to simplify the fraction before you split it. So keep those in mind. Try to look a step ahead before you write and see which one's going to give you the easier time. In this case, splitting then simplifying worked. There will be cases where simplifying first before you split it into two separate problems will be easier on you.